טוב, אנחנו מיד מתחילים. כפי שאתם יודעים, הנושא של האקדמיה זה סדרת הרצאות שקבוצת פרגון, קבוצת ברנע, מעבירים על ידי מרצים מהארץ בעולם, על מנת לחלוק את הידע שנוצר עם השנים בחברה, במגוון תחומים שיכולים לעניין אתכם. היום בחרנו בנושא של הרצאה על שריפה ברכבות, מאחר ובישראל נושא הרכבות תופס יותר ויותר עניין ותשומת לב, והתווך התת-קרקעי, מטרו, קרמלית, כל המנהור, המנהרות בדרך לירושלים, וכל התחום הזה שהולך ומתהווה יותר ויותר בישראל, בחרנו בנושא הזה, ואני חושב שאנחנו בחרנו במרצה יותר טוב ממרצה שבחרנו, אני לא חושב שאפשר למצוא, רוגר דירקמאייר, חבר יקר, מנכ"ל פוגטק, רכבות. פוגטק היא חברה שעוסקת בתחום הערפל מים, Waterless, וערפל מים, טכנולוגיה שאולי רוגר ירחיב עליה. היה לנו כבר בסדרה הקודמת מספר הרצאות בנושא הזה, ורוגר פיתח ממש בעצמו פיתח את כל נושא הכיבוי אש ברכבות בתחילת שנות ה-90, באמצע שנות ה-90. אז אני אעביר את הרשות דיבור לרוגר, אבל רק שנייה אני הייתי רוצה שבמהלך הסשן, אם יש שאלות או תשובות, שאלות לרשום אותם או בצ'אט או ב-Q&A, ואני אאסוף את התשובות ואת השאלות, ובסוף אנחנו נקיים סשן של שאלות ותשובות. רוגר, I made the introduction, and the crowd is waiting to hear about your experience.
Okay. Thank you very much, Omri. Thank you very much for being here. It's a great honor for me to give a presentation in this group of people here. As Omri knows very well, I like it so much to be in Israel, and I'm so sad not to be in front of you personally, because I think this is also a big issue we all are missing to meet personally. And so we have to try to make best of the situation. And I think with the ideas Omri presented here with this academy, we have a great opportunity to still stay in connection and to transfer knowledge. So thank you very much, Omri, for that. Good evening all together, good day, and I'm so happy to speak to you today about fire protection in rolling stock. There will be several topics, technology, standards, challenges, and innovations, what we would like to speak about, and some things from the daily business which we detected, which has to be solved, and where I think that the right answers could be provided with the right partner at your side. As I already said, Omri said, my name is Roger Dirksmeier. I'm the Managing Director, Rail Systems of Fogtech Fire Protection in Germany. And besides the topic of fire protection, I developed myself more and more into the mobility sector. So today I'm also a member of the presiding board of the UNIFI, the European Railway Industry Association. I'm the Vice President of the International Monorail Association, and I'm also the SME Chairman of the European Railway Industry, to take care about the needs, interests, and doubts of these small and medium enterprises in the European railway business. A quick view to the agenda for today. I will present Fogtech, as we call it, Fogtech in a nutshell, in a very short, summary about Fogtech. And second part will go to the Fogtech technology. In section 3, give me just a second. I'm really sorry, I forgot to switch off the phone before. In section 3, I will give a short report about the actual standards in fire protection, because we're directly linked to EN 45545 as myself to the working group. My colleagues are working on the NFPA 130. So there's a direct link, and there are a lot of activities right now. And this I would like to give a short overview about. Then I would like to talk about safety in railway systems. In part 5, we will shortly talk and present some aspects of the smart concepts, how to increase the efficiency of underground transportation facilities. And at the end, we also would like to make a short link to new energy carriers, because this means clearly new challenges also for the fire protection. In new energy carriers, we have still the discussions around the world, I think, that everybody wants to become greener, but still there are gaps in the knowledge of fire protection along the whole life cycle of the components, batteries, hydrogen, whatever it is. Few words about Fogtech. Fogtech is one of the last bigger fire protection companies, which is still owner managed. 100% of the ownership is located in the company. Fogtech was founded in 1997. The team is working with partners in different countries and is mainly a team of engineers and is doing a lot of development by themselves. So the experts in Fogtech are in engineering and design of complex firefighting and fire detection systems. A lot of services are included, like consulting and development of fire protection concepts, but including all the verification and validation also in up to full-scale fire tests. Within the last more than 20 years now, Fogtech became in its market one of the leading companies worldwide, and the part we are talking about today, rail systems, means railway vehicles. Fogtech is also the market leader worldwide. The activities of Fogtech are covering a quite big surface of our globe. On all continents we are available, as well as also the Antarctica we are active, protecting Antarctic research stations. We did several for, I think it was 4 in the last 5 years, to protect the risks there, to protect the people in this really harsh environment. Fogtech itself, the main office, the headquarters is based in Germany, in Cologne, but there are also 3 daughter companies, one in Austria, India, and one in China. The 3 main business units Fogtech is working in are the so-called fixed systems, which are covering industrial application as well as building applications. The tunnel systems, which takes care about underground facilities, underground infrastructure. And the part we are also speaking about today, the rail systems department, which is taking care about all the rolling stock, the track guided vehicles, where, as I already said, Fogtech is world market leader in active fire protection systems for rolling stock. What does it mean when Fogtech is working in this field? The rail systems team is a system provider for active fire protection systems in rolling stock applications, means it's not working on making transfer from building or aircraft business solutions to the railway. It's on the to develop on the spot for rolling stock applications. It's a system and integrator with full verification program, with a wide product portfolio on different levels of technology and safety. And it's a full-time rolling stock team, which delivered more than 17,500 systems to the market. And if I speak about systems, I mean systems covering a whole train and not counting each car. So it's really covering trains and locomotives in this way. And the big difference to other fire protection companies especially is that this team is really taking care 24/7 about trains, locomotives, track guided vehicles, and not one day a hotel, one day an archive, and one day a train. The technology Fogtech is using is more and more based on own developments related to the railway industry, especially optimized for this field of application, having fire detection solutions on different technical levels, depending on the requirements from the customer, water mist, gas extinguishing and aerosol extinguishing systems, and on the detection side, working with smoke, temperature, linear heat detectors, aspiration systems, the whole field of different kinds of products. Where we are coming from, and this is what the name is related to, Fogtech is showing the water mist technology. And FogTech started in 1997, its first applications in different kinds of field, mainly building, but we also supplied the first fire protection system for trains to the Indian Railway in 1997, in the year where we were founded. Waterless technology means at the end to split water in very, very small droplets to create a big reaction surface. And the reaction surface you can create, for example, from 1 liter of water is giving also an impression, a parameter, how efficient and how fast heat and energy could be transferred. Means as bigger as the surface is, as faster energy can be transferred. A big droplet with 1 millimeter diameter, which creates from 1 liter of water, maximum 2 square meters. The heat and energy needs time to change the water droplet to steam, while with the very small droplets, there's so less mass that it's immediately changing to steam. And so the water mist could be created with the numbers of, with the big surface from small droplets as shown here, we can create from 1 liter of water up to 200 square meters of reaction surface. Energy could be transferred very, very fast. And this energy binding potential, this could be also shown then or seen in the temperature decrease immediately after activating such a system, like in the graphic in the middle, when with activating the system, the temperature is decreasing immediately to a much lower level, and the heat is transferred and the energy is bound by the water droplets. At the end, directly at the flames, where we have change of water droplets to water steam, there's also an effect to substitute the oxygen from this place by gases, by the water steam. From 1 liter of water in liquid phase, you could create 1,650 liters of water steam, which means also a displacement of the oxygen, but only directly at the flames where the big energy can be transferred. And in the rest of the room, the oxygen level is on, oxygen concentration is on the level like you need it for human protection. So how does it look like then in a train, such technology? You see here a cross-section of the high-speed train, which is a graphic with our system and components around. To give an example, an idea, how does it look like the system, how it should work. You have smoke detectors in the ceiling place. These smoke detectors, how they are placed or in which way it's validated where to place, you will see later. They are connected with the central unit, which is, as you can see here also from the components, not a classical fire protection central. It's really a computer unit designed for rolling stock applications. If a fire started and the fire is detected by the so-called two-detector dependency, and we developed an algorithm which is called dynamic two-detector dependency to avoid any unwanted activations on the train. So means a specific environment has to be created that the system is accepting as an alarm, and to avoid any influence to the system and operation of the system by smokers or more simple events. Because as you know from the railway, as late as possible, the fire should be detected here to avoid any interruption of operation of the system. If the fire is detected, the high pressure water mist system then will be activated, and the water mist is supplied to the area where the fire is detected to extinguish the fire and to make the situation safe again. In the underfloor area and the technical areas, in this example, aerosol generators are used where a fire is detected by linear heat detectors inside, communicating with the CPU again, with the central unit, and then activating the aerosol generator unit to extinguish the fire. And just to give an example, how does it look like in reality to have a water mist system integrated? First, we have a passenger coach, a metro car in Germany, where a water mist system is integrated. And what you could see here is how two nozzles were activated within this passenger area. And we see this great energy transfer, which I explained before. It's possible to reduce the amount of water which is needed for the firefighting, for the fire protection. It is possible to reduce the amount of water here to 2 liters per minute per nozzle. Means in total on this train here, on this metro train, we are carrying 60 liters of water to protect the train by 10 minutes spraying time and 3 to 4 nozzles activated, depending on the zone where the fire is detected. What you also could see is how the room was filling quite fast with a fine water mist. You still can see to be evacuated in the right way, and the fire will be covered and securing the area. And this is also a point which is very important for the approval process, that the people standing on board can stay in a surroundings of the fire with a distance of 2 meters without any danger or any problem to their health. And you will see with the next video, which is in this case taken from the type test we did on the Israel State Railway generator wagons with Bombardier a few years ago, that the design of the water mist is also a lot depending on the application. While in the passenger area, there will be a risk like from vandalism, a burning bag, a burning newspaper, but in general, a quite slow fire development, while we have in the machinery spaces, oil, diesel, and maybe other stuff which burns quite fast with high temperatures. So a very fast increasing heat release. For this reason, the density of water mist is a completely different one. To give another example, in a diesel multiple unit, this is a video, as you can see, from 2004 already. So it shows also a little bit how long we're doing such a this business. And this was during driving with 120 kilometers per hour, where we put a glass into the maintenance access and making this movie during driving to show how this area is filled, even if the wind is coming in from the front side. This is just to give an idea how this would look like. Then what I think is very important to be always up to date is the activity in associations, on normative groups, on standard committees. So these are an overview about the associations and organizations FOCTEC is active in. The railway industry, I already mentioned, European-wise, German-based, but also the International Monorail Association. Additionally, then we have the SEN committees, the standardization committees on European level, on American level, Italian especially. Why Italy? You will see later on. And then there are also big research projects like Sovereign and Solid. Sovereign is taking care about new energy carriers, risks from battery and hydrogen, while Solid is related to tunnel protection. Of course, there's a lot of paperwork, and paperwork will be also a topic later on. But paperwork also on certifications. FOCTEC is a certified welding company for components on rolling stock. Is IRIS certified since 2009 and also ISO certified already since 2001. Some of our OEM customers we are supplying to. Our biggest customers last year were Stadler, Bombardier, and Siemens as the 3 big ones. But we also see that the Eastern companies like Hitachi, CRRC are coming more and more and taking also a big role for FOCTEC actually. Some references I will just jump over on high-speed trains and intercity cars, special urban traffic references like monorails, light rail trams, light rail vehicles, metro cars, locomotives and special equipment trains for maintenance, and also cock railways. Fogtech protected the steepest, the longest, as well as the highest based cock railway in the world. And you see here also some of the references we already have done in Israel, like the trucks locomotives from Bombardier, the former Foslo, now Stadler locomotives, double-deck trains, cars from Bombardier, as well as the generator wagons from Siemens. And in the middle, as already mentioned, if I understood right, from Omri, the Carmelit with a protection system for the passenger area. But what is happening around? There is the standards we have in the background, and you will get just a short question to give you your feedback, because when we talk about fire protection standards, I would say mainly two main standards are dominating now more and more the world: the EN 45545 and the NFPA 130. So if I'm right, you have always up to 20 seconds to answer some questions in between, which will also come later on for some other slides. And then later on, we will see how the results are. So this was, I was expecting in this way for the Israel region that NFPA maybe is more dominating than the EN 45545. So, but that means also that one point of my presentation, a few slides later now, will be very important for both of you. So we will see this then further. First of all, having a short look to EN 45545. The working group taking care about is the working group 01 from TC, Technical Committee 256. I would like to give a very short, brief overview about the status of part 2, the revision work which is running right now, and then for the some special topics related to the ISO as well as to TSI. The status quo right now for the working group is that in general we can say they are responsible for the fire protection and rolling stock standards. Revision work on all parts is starting. For the EN 45545, we had first round already, and next week there will be another 2 days for the next parts of the EN standard on European level. For part 5 and a little bit part 2, there's also some support from Senelec, the electrical committee, because part 5 is related to the electric parts of the train. There's 3 task force working, one for toxicity, one for seats, and one for FCCS, which means fire control and compartment system, where already a new number is released as an EN, but actually a pre-EN 17532. And the new task is coming up for numeric fire simulations, where the CEN has the idea also to give more standards to that. For the seats, standard is already published, 16989. For the toxicity standard is also published under the number 17084. And for EN 45545, the second part, the phase 1 is already done the work and is already published also as EN 45545 part 2 2020. But how to work with that? Because the TSI, the technical specification for interoperability, which is not a topic for Israel, I have to agree. But in Europe, it's creating now trouble because this TSI is referring to the older standard. And this brings some strange situations now to the European markets, and not that non-TSI vehicles, means vehicles not running on a TSI network, European network, can already use the new one or the old one, they can choose, while for the European network, which is referring to TSI, they have still to use the old one. So at the end, actually, it's a little bit that the people have to discuss and to clarify the applicability with the contractual partners and the approval body, the authority. And so actually we speak about a transition period as long that the older version can still be used. But this is a really big topic that the TSI standards are not automatically referring to the latest version of a standard. The revision work on the EN generally has normally checked every 5 years. So 5 years after release, there's a survey to check if there is a need of revision work, means validation against experience and further needs. And if there is a view from people that a revision should be done, then there should be consensus between all to get it started. And this is already done for all parts of the actual version, means all 7 parts are under review and will be reviewed in the next time, where I would expect something like 3 to 4 years from now for final result in a complete new 45.545. Actually, they are working on part 3 and 4. These are the first two, the two which are right now under review. And for the part 2, released in 2020, there's already a proceeding of an amendment because there were still some failures in the references as well as in the forward. So you have to see, if you look to the latest standard of part 2, you have to refer to 2020 and the amendment. The one big topic is then that, and this is exactly the situation we could also see from the first question from the survey, that we are jumping around the world as a supplier, as a partner, as a planner, as a company, and we have to change standards from country to country or region to region. So there was a proposal now from Working Group 01 to the ISO committee to set up the fire protection standards in a worldwide standard, an ISO standard, and this should be based on the EN 45545. This brought a lot of intensive and interesting discussions, but at the end, from all sides, very positive feedback. And so now next steps are the application for the work items and to set up the working group on the ISO. And so actually, I would expect that somewhere in the future, there would be one joint standard to cover the fire protection things in rolling stock and railway. But as you know, standardization work takes a long time. And so we will see when we can reach final result on that. And this is a very important topic, what you were giving here as a result, because this would be also feedback I would like to give to the ISO committee next week when we have also our meeting with the CEN committee. So the opinion of the people using the standards or having to make use of the standards is very important, I think, and this I will transfer also to them, to the committees. Oops. With the TSI, I already mentioned one topic. I think this we can just jump over, as the TSI is not referring automatically to the most actual version. We have still this gap always between old standards and a very new one when the TSI is not following. NFPA 130 is right now also under review. There was a big round in November through several days as an online meeting to move forward the standards. I think this is, from my point of view, much better cycle, what they do than for the EN standard. Here, every 3 years, and this since 1982, every 3 years, there is a revision cycle, and not the way to ask every 5 years, now, what do you think, should we do something new? Because there's a development in the market, and in this way, it helps to keeping it always up to date. The big difference between EN and NFPA here is that EN is taking care only about the vehicles, while NFPA 130 is taking about the complete system, which I personally see as a benefit that you have in one standard, the whole system. Because thinking in parts, we do much too much. I think to make everything most efficient, it's always important to think in systems, so to have a holistic approach. And for this, NFPA 130, from my point of view, from the general philosophy, is a very good base for. It does not mean that all topics I agree to, which are mentioned in, but in general, the overall approach, I fully agree to much more. And a little bit compared to EN 45, 545, we put here the different parts in relation. So you can see that later on also. I will not go too deeply in that. But two main topics I would like to bring up about the actual discussions of NFPA 130, about the active fire protection. In the past, and even today, the NFPA 130 is not really taking care about active fire protection. And starting with 2014, there was first time an annex called Annex G involved, where compensation measures were given by using an automatic fire suppression system, mainly in the passenger area, to protect the people. And where it was described that this can limit fire growth, and that this could also influence the design of stations, the design of ventilation systems, and so impacting the infrastructure in a positive way, if you see it from the volume to invest way, and so to make it more efficient also cost-wise. During the last discussions, another topic came up that may you know that in US, most cars are close to each other, especially in the metro area. So maximum two merit pair cars are used. And now in New York, I think first time real open gangway philosophy is followed. And it's more like a test trial on 10 trains out of the big order they placed to Kawasaki. And so now it's a big discussion how to avoid any spreading of smoke and fire from car to car. And of course, also for this, a fire suppression system could be a solution. And this is under discussion. And for the 2023 edition of NFPA 130, there for sure will be a bigger part on one side for fire fighting, fire detection generally, but also for the open gangways, the open gangway philosophy. Big challenge actually is component listing concept, because you have these components which we also tested in different ways between NFPA and EN 45, 545. There will be also development for the next revision. And for this, of course, a joint ISO standard could be a very, very good solution to make also this more efficient. But at the end, it means also everybody has to agree to the standard. And this makes it quite complicated to find a joint solution. There are two other standards I would like to mention quickly. In Italy, after the big tunnel fires, there came out a law that all trains have to be protected, which run through a tunnel longer than 1 kilometer. Means all trains have to be equipped in the passenger area with a water mist system. And this is legally requested in Italy. I found it quite strange. Of course, for our business was a very good development, but this was really, and I think Italy is still the only country worldwide requesting that. But this was a reaction to the big tunnel fires and a lot of dead people, which the Italians have to claim after, I think it was 1999 starting to 2001, where we had a row of several tunnel fires. And so this standard came up, this law, this Decreto Ministeriale, where this is requested. And the UNI, this is the Italian Standardization Committee, has to develop a standard in accordance to that, how to implement to a train and how to test such systems. So could be seen in different way. On the one side, it's an optimum to protect passengers. On the other side, it's questionable if it's really necessary, always to have all systems on board and to protect with all potentials. And I see from the answers I'm with you that project-specific decisions should be, but in Italy, it's still clearly by law claimed to have such trains protected. First version was published in 2014. Actual standard is valid from 2016, and in Q3 of 2021, the next revision is planned. So the guys are just working on that. Also, our Italian colleague of FOCTEC is working within this working group. There's some guys, this is not such important in the moment. This is a bit comparison to the other norms, but you will see this later on if you go through, but you can also contact us every time if you want to get more information about the way of proceedings. I just want to jump to the AGE guideline. This is a standard created in 2007 first time, so published 2007 first time. The working group on that started in 2002, organized by the 3 TÜV organizations in Germany. And the point was that there are standards requesting a fire detection firefighting system, but nowhere was described how to validate, to verify them, and how to check if the systems are working right. And so these 3 parts came up, part 1, fire detection, part 2, firefighting, part 3 for system functionality, and also some safety topics. And actually version 5 from 2008 is valid. Here we have a 2 to 3 years revision cycle to make it most actual always, with all the things learning every year from checking, verifying, and testing. As I said, we have 3 parts, and there's also described in a good way how to test them with the smoke generator, and how to make the fire test, how to have standardized fire test to check the effectiveness of such systems and the performance. And if we speak about topics like that, of course, we have also to speak about safety. Safety here, I mean functional safety. And within our company, we set up a few years ago a specific team only taking care about that. So if we speak about safety, which comes mostly with the customer's requirements first, but their requirement should come from a risk analysis. And what we detected also, to be very honest, that it is preferred maybe to be safe, to be sure, not to make mistakes, to request a higher safety class than you really need. From the risk analysis point of view, to monitor what is the risk on site, the risk of the operation, how to evacuate people, we could see in a lot of cases that people unneeded increase the number of the safety level, which could be rated between 0 and 4. So in this way, really, it's always our recommendation really to go to check what do you need really, and then defining the safety levels which are requested. And we see that unfortunately this text parts are in German because the specifications was translated to German, but it's not really in one line how the people are requesting things with safety. So still a lot of knowledge is missing in this area. Still the people want to increase the number to be sure, which creates a lot of efforts and costs which are not necessary. And so from this way, it's really a topic we have to educate also people much more in a lot of cases. And for this reason, in a project, you have always the situation at the beginning, the requirement level, where you have something from the analysis, then you have a discussion with the experts, and then it's going forth and back a little bit to find at the end a solution, what is the right way to proceed. And FOCTEC has a specific approach, as I said. We set up a team for that now 5 years ago, which is taking care about safety and zeal requirements in a very detailed way. And Our approach is to have a fully certified ZEAL2 hardware and software solution available for the market for the customers, because there is no half ZEAL, there is no half safety, there's safety or non-safety. And for this reason, it's really important also to understand that systems which should be ZEAL certified, that they have to be ZEAL certified with all the requirements around. What you can see here, that we started for the actual series of our products in 2012, the today called BI level version, which means basic integrity level version. And this is starting from the lowest requirements level of safety. And then we increase the system, the single components to further and further to the higher levels until a fully certified ZEAL2 system, which hardware components as well as on the software base. This is a modular solution, highly flexible and full redundancy in communication. And this means, and this is really important for me to mention it to you, because a lot of people speaking outside about ZEAL and safety, but if we speak about safety, it's really important for all the components to have them approved against EN 50155, EN 50126 and 8. The software assessment have to be done in regard to the EN 5657, and the complete system assessment, and this is at the end, this is what brings you the ZEAL and safety certification, is the EN 5129. And we see a lot of people running around talking about ZEAL and safety and providing then part solutions with some smaller things, maybe a safe relay or something like that. And this is not the way how safety has to be understood. And at the end, if everything works well, you see on the right, this is some kind of inspection certificate for such a ZEAL system, which you can provide them for your system. Safety means also, we already mentioned the EN 5657, which is the software standard right now, how to program and how to handle software. And this has a huge influence also to the organization of the company and the structure and how development processes have to run. On the right, you see a table of documents which have to be created for the software development only to demonstrate that you did in the right way and you checked every step and how it was proceeded. So at the end, a lot of paperwork again. And for this reason, we have to ask ourselves, does more paperwork really helps to make systems more safe? But please, and this is really a recommendation in any project, ask yourself seriously, what do you need? It's not necessary to increase safety standards only to feel better. It should be a specific reason from the risk analysis behind why you need a more safer system. But if you decide for it, please do it in the right way and not with partial solutions. And doing in the right way, also smart concepts is a very good example for, because with this solution, we could demonstrate with operators together how to optimize and how to create an underground and infrastructure and mobility system much more efficient. The basic situation with this case study was that we had an older metro car, in this case in the city of Essen in Germany, and they had a lot of problems because the approval body requested them to rework on all underground stations as they have had a topic with the evacuation concepts. Means they had to demonstrate how the station, the underground station, is affected if a train is burning at the platform, standing at the platform. And for this, we have several different curves. If you ask different operators, all of them have different curves for heat release development. And the people from Essen, in this case, did fire tests by themselves. You see the pictures on the right where they burned a full train and partial parts of the trains. And then they created out of that this black line here, the black curve, the Essen-Leipzig Versuch, as it's mentioned here, where we had a development up to 35 megawatts for the train, which of course could not be handled by the old stations they had. So Then that we got in connection, we did a milestone plan, how to optimize a fire scenario. And with the different milestones, which we agreed also with the approval body, we started then to validate different ways of, with different solutions for the trains, for this kind of trains, to implement a fire detection system, doing smoke tests on board to approve, to validate a solution, how such a train could be protected. Afterwards, a full-scale fire test with original material, with 4 different test scenarios with water mist system, and then 1 hot test as a verification and comparison to the activating test. And I did a big mistake during this test, to be honest. We were monitoring the fire test. We did a lot of pictures, but we should make a picture or a movie of the face of the customer when we did the hot test, when he saw how good his material is burning. Because this material here was approved against DIN 5510 from older times. But after some years of use, with all the people sitting on there, having cleaning materials on the seats, it's not with the same behavior like at the beginning. And you could create a quite nice fire on that. And with the fire protection system on board, we could demonstrate that the fire curve was suppressed immediately. You can see from this curve in the x-axis the time and the y-axis the temperature. You can see that the temperatures, besides the direct flame temperatures, which is a red line, are not increasing so much, only a few centimeters on top of the ignition source. The yellow line was coming up a little bit, but the fire was suppressed. The flames, of course, were fighting against the water mist, but the fire was not spreading and could be controlled in a very good way. Based on that, the system was designed, integrated to the train, where you can see here. We did also some further calculations on the car body, how to integrate the cylinders and the systems. And at the end, there was a 60-liter water cylinder has to be integrated to the train. The smoke detectors into the ceiling, the nozzles, the pipe work, and all those things around. And then final step, the type test with the approval body. You see on the right pictures from the type test activating during the people are standing in. On the left side, you will see me explaining to the people, to the experts, how does it work. And you can see also I was much younger during this time. And hairs were not so long like now when all the hair cutters are actually closed in Germany. But the most important, if we see the fire safety, fire scenario curve again, there was a new line now, the green one. And the green one is the one which the approval body agreed to, the operator can use if a fog tech system is on board. Means from the black line, which they had at the beginning in Essen, so they could change to the green one when using a fog tech system in the trains. And depending on this equipment of the train, they could also raise 2 different scenarios for the modernization work and investment in the underground stations. And compared between the black and the green line, there was a difference for the investment in the stations and including equipping the train then for the green line, a difference of 89% in the investment. And this is where I would say that the smarter way of firefighting is not in this way also creating commercially very, very interesting case for each operator. So there's a very close relationship, of course, now, because we became something a little bit like a hero for them, as we could help them to create this scenario and to realize such lower amount of investment which was needed to upgrade the stations. Last point of my presentation, I would like to jump to the new energy carriers, which brings new challenges to the fire protection topics. As we already said, more and more regions, more and more countries want to become greener and greener. But along the life cycle of batteries, hydrogen solutions is quite unclear, or is it still a big gap in knowledge for the fire protection. We have very high density of energy bounded in a very small volume. And to get this under control, this is a big topic for all in our society together. For this reason, there's one research project, which I would like to recommend to have a look in for everybody who is involved in such new energy carrier topics. It's about the safety of urban underground structures due to the use of new energy carriers. Means how I have to handle a parking house, a tunnel, if now a car is burning there, and maybe I even not know if it's a battery-driven car, means fire is very local on the car. It's a fuel car where maybe the fuel is running out and will be on the floor, or it's a hydrogen car where the hydrogen is under the ceiling and it starts to burn. So all these cases and scenarios are not finally closed. And for this reason, there's a lot of need for research around the world, I think. And for this project, there was a Federal Institute for Material Testing, the Fogtech Fire Protection, as well as the Underground Facility Association, for the Research Association, which started this project with associated partners from Ineris, CETU, Deutsche Bahn, as well as the Fire Brigade of Munich, and supported by the Ministry for Education and Research. The whole project ran for 3 years, was closed end of last year. And the report of this will be also published quite soon. But first results, of course, you can already find in the net. I will give you later on also the link on to the web page. Where is this coming from? The motivation for that, as we already said, more and more use on that, but gaps in standards, gaps in knowledge, and we have to close this to get this situation generally under control, and not to open new challenges, new risks to people using that. And if we speak about new energy carriers, we are referring to batteries, under pressure stored gas, as well as liquid biofuel, which are, let's say, the new way of traction power. And just to give an idea how it could look like. This is a video done from Stockholm. Sorry. Maybe you know this one. But just to give an idea, how does it look like if risks are not managed right? In this way, it's just with the cylinders on top and not taking care about the height of the road, of the tunnel here. And here another video where we see a living room and an accumulator recharging for e-scooter. Maybe you know this video also from the internet, but I think both these videos shows extremely well how risks could happen to our daily life if we not manage them in the right way. Do not get me wrong, I don't want to make you afraid about these technologies. It's just from my point of view that they have to be handled right, and that we have to know about the risks and how to manage them. But to create this knowledge, how to handle them, from the new risks and the missing knowledge, we have to combine it in a research. And this is running now with this Sovereign project where the first parts are done. And the next one is now starting to be released for full-scale fire test, also in tunnels with new energy carrier cars. And here you see also the link for the webpage. And this is my last slides. And also from the fire tests here, we could see as a result that for the fire scenarios, for new energy carriers, new scenarios could be set up. There's a new standard now coming out also from this project for parking houses, how to design them if e-cars are in, if hydrogen cars are in. There were a lot of tests done for fire detection technologies for battery fires, and which way to detect in the right way and the fastest way, how to fight them. And maybe you already know that you not really can extinguish a battery fire, even if companies unfortunately telling you that. But if a thermal runaway is starting in a battery, you will not be able to extinguish the fire. You only can try to cool down the area around and to reduce the spreading of the thermal runaway. So this is a very big topic, and the official report will be published in the next month. And there now the next step is starting the full-scale fire test in tunnels, I think, which will be quite exciting for all of us to see what will happen there. Just to give a brief overview about that also, and I think I did it within nearly 1 hour. I'm sorry if I was too long, Omri, but there's so many messages to be placed to the market. And thank you very much to Gary, gave me the opportunity to talk to this great audience, even if I could not see anybody personally. Thank you very much to all of you for attending and listening to me. Thanks a lot.
Thank you, Roger, for your time. And I really feel pity that the crowd could not see you online, because I saw you a few times, not online, a few times performing on a seminar, and it's a great performance.
Thank you.
Some questions are arising. I will screen it because some of them are regarding to, as usual, to the Israeli regulation. There is one question about any fire system, extinguishing system for rails from generated by hydrogen. I don't know this kind of train. Maybe do you know it? You know it.
We have the first trains running with hydrogen power in Germany. Also, right now they are running again on a test line. There are 2 trains from Alstom, the Alstom Salzgitter in Germany. It's called E-Island, and this train has a hydrogen tank and is using also fuel cell technology. And they are still on a test, but I think they are running since nearly 2.5 years, something like that. I would say, and a lot of people agree to that, they are already approved for use. And there's also first order now out of, I'm not sure, 17 of 24 trains in the north of Germany, where Alstom got the order for this trains, including the whole infrastructure for refilling and all the things around. Actually, on these trains for the hydrogen tank, there's no firefighting system for that. They have a detection system integrated, but there was no request actually for a firefighting system.
Okay. As I see, your lecture was very clear, because most of the questions are not related to your lecture, are related to Israeli standardization. I will just say, very quick overview, that in Israel, the tunnels are regulated under the NFPA standard, and the train itself is regulated under the EN standard. So it's kind of a combine between those 2 standards. While we were doing the Carmelit project, we used the ARGE and the EN standard together. And the Israeli rail services are, all the systems are tested according to NFPA 750. The installation.
Yeah.
This is what we do here in Israel, the test. Okay. Some people want to thank you for a very important lecture. Thank you. And I'm very pleased that the crowd also liked your lecture, and I wish you a good evening, and see you soon in Israel.